So we're finding the static angle of friction for PTFE on PTFE dry and steel on steel dry. Now PTFE is polytetrafluoroethylene. It's the same thing as you see in frying pans, the Teflon. It's a very low friction coating. But you also see it on sometimes bridge bearings. You get PTFE bridge bearings, and you'll see it on mechanical systems as well. Kind of sliding bearings will use PTFE. So to get the static angle of friction, first you need to know the coefficient of friction. After that, it's dead easy. Excuse me. So it will be on my uni, but I've just got those in a little notebook that I keep. And got PTFE is here, clean and dry, so it's 0.04. So let's go back again. So for PTFE, the static coefficient of friction is 0.04. And the angle of friction is just equal to inverse tan of that, which is equal to tan to the minus 1 of 0.04, which is equal to something quite small. So just stick that in my calculator. Oh, 0.0, excuse me, 0.04 is 2.29 degrees. Okay, so it's got a very low, so remember this angle of friction. If you've got your normal like so, your friction like so, so this angle is just the angle between, so you got, this makes a resultant, and so that would be your normal force. This would be Fs. So mu is just equal to Fs over n, and so you would have Fs would be like so, excuse me, still got this cold. And so for a very small angle means a very small friction force. So this low angle for PTFE means that it's got very low friction. For steel, on the other hand, this is equal to, let's have a look. So if we could jump forward to that again. Look for steel to steel clean and dry. So it's somewhere between 0.5 and 0.8. Let's just take the mid-range of that, which would be 0.65, I think, wouldn't it? 0.65, yep. So we'll just take the mid-range of that. And it's very dependent on the surface preparation of the steel. Let's take 0.65. So we're using the wrong letter there, sorry about that. It's phi they usually use. So for this angle of friction, so phi s is equal to tan to the minus 1 of us, which is equal to tan to the minus 1 of 0.65, which is equal to 33 degrees. Okay, so when you get this higher friction, you get a higher friction angle, 33.0 degrees. And obviously you could do this the other way around. If you were given the friction angle, you just take tan of it and you'll get the coefficient of static friction from that. Nice short one.